Hi, everybody. This is another remix episode where we revisit previous guests and explore a topic they all discussed. This one is about hydrogen. I had the privilege to talk to well respected experts, starting with Ivette Perez, who gives us the rundown about the hydrogen industry here in Canada. There's Mark Kirby, who gives us a Hydrogen 101 crash course on how it all works. I introduce you to Dalhousie University's Mita Dasog, who talks about her research laboratory. To top it all off is Nirmal Ghanapragasam about the Canadian Hydrogen Safety Council. There's much to look forward to, and it's coming up next. How is the business of hydrogen changing in Canada? Do you have any examples of how it is?
So there's it is changing, and it is changing very rapidly. And what I see is that there's an increase in interest and understanding of hydrogen since the 2020 launch of the Canadian Hydrogen Strategy. There has been a lot of interest in Canada, also internationally, and then you see the number of partnerships between the East Coast and the EU, and there are also new partnerships being formed between the West Coast and the Indo-Pacific region. So a lot more activity in the sector that resulted in new initiatives, new funding, and hopefully very soon finalized legislation for the clean hydrogen ITC. So a lot more activity in the sector, major projects under consideration, no major projects at FID right now, but I believe that is coming.
Right. Transporting ammonia, from coast to coast, it has a lot of complexities. We're not a flat country. I mean, there's, you have mountains through. So can you tell me what some of the challenges would be?
Right. So, I mean, transporting hydrogen in general, right? It is clearly a crucial part of the process of bringing the product to the end user or to the points of shipping, for example, right? From production point to whatever that hydrogen is going. The options to consider, and I don't think that we will be speaking about literally from coast to coast moving hydrogen or ammonia, at least not now. There's the European backbone being developed, but we're not there yet, right?
Right.
So the options to consider when we are moving hydrogen via hydrogen itself or carriers would be one example: pipeline, ammonia by rail, and then when we ship to other continents, the options would be ammonia, which is an option that is very much present and likely the one to soonest happen. And there are other carriers as well. There's methanol, there's liquid organic hydrogen, and each of these have complexities. Now, the logistics of moving ammonia is actually quite well known, and this is a positive. Now, obviously, moving ammonia in the volumes that we're talking about is novel, and so ensuring the loads can be costly, and also it's just important to do it safely and smoothly. It's really important for the industry to ensure safety. So that that awareness element, that education element, together with moving hydrogen in whatever carrier it is safely, can provide that added reassurance to industry, to government, to the population in general, right? To you and me.
But you mentioned clean hydrogen. So what goes in the making of that?
So the definition of clean hydrogen and or low carbon intensity hydrogen is just exactly that. Is that from well to production point, or where the source to production point, there is little or no carbon dioxide emitted into the atmosphere or the greenhouse gases. So the key thing is that when it's in its overall production process, that there's very low emissions of CO2. Now, so if you do that with water, splitting water and using clean electricity, there's little or no GHGs emitted. So that is very much clean hydrogen. And if you use renewable sources to produce the electricity, then it's what's called green hydrogen or renewable hydrogen. Now, that's great, but there are also other ways to make hydrogen, and some of them are very cost competitive. That is to tear apart hydrocarbons. It's, as by the word says, hydrogen and carbon are mixed together in things like natural gas and oil, even in things like biomass. So if you can also reform those to release that hydrogen, getting you that energy. But the challenge here is, what do you do with the carbon part of it? Now, if it's emitted as CO2, then it's not considered clean hydrogen. It is what they call gray hydrogen or black hydrogen or brown hydrogen. But anyway, it's not considered clean hydrogen. But if you do that and manage that carbon, either keeping it as elemental carbon, as like carbon black, which is a useful product, or by taking the CO2 that's produced and storing it, sequestering it permanently in another location, in underground or wherever, then it's also considered clean hydrogen because there are no net GHG emissions. Now, the other key thing is you got to make sure that your source and your production of your whatever fossil fuel that's used to make it, or biomass, also doesn't release GHGs, because that counts. Right. So you got to make sure the whole chain from start to finish is low or no carbon intensity. The good thing is there are standards that are being developed globally to measure that. There are ways of doing that have very, very low carbon dioxide emissions. So it is very possible to make clean hydrogen from all sorts of different energy sources. And that's a good thing, because, as we'll talk about, we're going to need lots of hydrogen. And we need to get it in as cheap a way as possible. We need to get it from the energy sources that are available out there, and all the energy sources that we've got. So it's a good thing that we can make low carbon intensity hydrogen from many, many different ways.
Well, I was doing my homework for hydrogen. You can't talk about hydrogen without talking about fuel cells.
Yeah.
And I was trying to find out what the correlation is, and you could probably explain it way better than I ever could.
Right. So what we're using, what we want to try and do is, when we're using hydrogen, it's to, is part of our everyday processes, to heat our buildings, to run our vehicles, to do our industrial processes. One of the applications that you can do with hydrogen is to run it through a device called a fuel cell, which was developed in Canada, actually, by Ballard Power over 40 years ago, and has been in Canada as a leading country in the manufacture and sale of fuel cells around the world. What fuel cells do is they take that hydrogen and they react it with air in a very controlled way, much like a battery, and they produce electricity. Now, the good thing about that is you can use those fuel cells in a number of different applications. You can use them, for example, in a building as backup power, or in a big data center to back up your power, or even as a source of baseload power for certain applications in other areas. But the big area that fuel cells enable is transportation. Transportation in all its forms, transportation in aviation, in shipping, in marine, in rail, you name it. And that's because you can combine a fuel cell with a battery in a hybrid system, and you use electrical power to run your vehicle, just like any EV out there today. But instead of having to charge that battery, the fuel cell provides that charge and charges that battery up, and also works with that battery to provide you your maximum power. And to refuel that vehicle, you can put hydrogen into a storage tank on that vehicle to run the fuel cell. So now, instead of being tied to having to recharge your battery, you can very quickly and conveniently refill it with hydrogen. And the nice thing about that is that storage system, that tank of hydrogen, has a lot higher energy density. In other words, there's just a lot more energy in it than in an equivalent battery. It's also a lot lighter. And so that means you have a vehicle that is light, can be refilled quickly, and has better range. And now that means that we can have electric vehicles that compete in all transportation applications, not just in select ones, but now it can run heavy duty trucks, it can run trains, it can run even airplanes and your car. But your car may not be the primary area we use fuel cells. You may be perfectly fine with a battery, but there are many, many, many other transportation applications where that combination of fuel cells and batteries will enable us to get rid of internal combustion engines and running on fossil fuels entirely.
You created the Dasog research group, and so what are the primary goals? What you set out to achieve?
Sure. So I'm still a material scientist and chemist right now. So we have two sort of subgroups within our research group. We have one group that focuses mostly on water treatment, particularly desalination. And we have another subgroup that mostly focuses on sustainable green fuel production and focus being hydrogen there. And again, it's all tied together by material science. So we make nanomaterials that which we can then use for these applications. And we try to work within a few boundaries. So we have, kind of restricted ourselves. So the first one, the way we source our starting materials. So we want that to be a sustainable source, waste stream if possible. We want to work with elements that are abundant, that are inexpensive, that are globally distributed. So, it's a technology that might be accessible to everybody. Then we also work on the production. So we want to come up with methods that are scalable, that are low energy, and again, sustainable. And the materials we make, we try to engineer them in such a way that they last for a very long time, they perform very well, so they have high efficiency. And then at the end of their lifetime, it's easy to then take that apart and recycle it again. So these are sort of all the things we consider as we try to design our technology and our materials.
So about the Canadian Hydrogen Safety Center, it's recently began. It really, it's relatively new and getting off the ground. So when it is off the ground, or if it's not already, what are its objectives?
Right. So the center is going to be a membership-based organization, and we are trying to incorporate it as a not-for-profit independent company. And mainly for one reason, we want the safety solutions and safety issues addressed before the industry starts building the hydrogen economy in Canada. So one of the things we are trying to do as part of the center, like the primary objective, is forecasting problems before they occur. So this is something we have achieved in the nuclear industry, so especially on hydrogen safety. So we have forecast issues for the stations. We have come up with solutions. We have tackled those problems. So you don't hear anything about the hydrogen safety aspects from Canadian stations in the Canadian designed reactors. So the forecasting of problems is a bit of a challenge, also like more like a chicken and egg. So the industries are saying, okay, we don't handle hydrogen at the moment, but how are you saying we will have problems? So we basically look at that from the first principles and fundamentals of engineering and science. So we look at what they will do with the hydrogen in the future and what it could trigger in terms of a problem. And we say the problem is occurring, say, 5 years from now. We walk backwards and say, okay, how do you fix it ahead of time so that you can solve it? And in doing this, we need to coordinate people, we need to coordinate different organizations, we need to coordinate researchers and the subject matter experts. So that coordination is the other objective. And then that trickles down into you need to develop standards, codes, and regulations. The next step to that is you're also in this process creating facilities, you're creating a network. So the industry needs to know who does what. So basically enabling that access. So the center becomes a single point of contact or single point of entry for the industry to say, okay, how do we get the safety piece covered while we develop the projects and other things? And then the final aspect or the objective of the center is the center could be accessed by regulators or authorities having jurisdiction as a independent advisor if there is a hydrogen event, if they do want to do a forensic analysis or anything like that.
Well, would you say, you want to develop kind of these templates, you want to kind of create an understanding But if you really want to get into the detail of it all, would you say that this is not a one-size-fits-all approach?
At the moment, yeah, like it is not one size fits all, and like the whole idea of creating a standard is you have replicating items available. So at the moment, everything is what we call FOAK, first of a kind.
Mhm.
So most of the projects are in that space. And so what we want to do is, if the same project is, say, if one project is happening in, I don't know, Nova Scotia, we want to take that. And if a similar project is being proposed in, say, Quebec or Ontario or Alberta, we want to say, okay, here is something that somebody has developed. We want to take it and apply it in these new jurisdictions. But then you start looking at, okay, what are the requirements from provincial or municipal levels in those regions? So we will add those layers. We'll discuss with them. So eventually this template could become a standard, or it
Right.
could become part of a regulation. So we are building towards that. So it's sort of the first few steps on that. And with respect to hydrogen, again, one size fits all is still coming. So we still don't have like a standardized hydrogen system. So each project has their own different sizes, and the manufacturers are getting towards standard modules. So, and the other interesting thing about hydrogen systems, most of them are modules. So basically, you can size it by saying, okay, I need these many number of modules. And centralized systems like large scale production, storage, they still are coming along. And so that's the key. One aspect is the codes and standards are like still evolving. There are different task forces and codes standards developers working on them. But there are also, at an equipment level, at a system level, you also need checklists, protocols, and guidelines. So those can be developed within a project, and those can also be made standardized. So, this is again very early stage in the industry. As I said, some of the larger companies, they know how to do it within their fence. They're trying to sort of bring that to this new world of hydrogen applications.
I hope this gives you a bit more knowledge about the exciting developments being made in the world of hydrogen. This podcast is sponsored by Smart Energy, an energy conference that is held annually in Halifax and in Vancouver. I'm your host, Maria McGowan. Thanks so much for listening today.